The chat is saved for those of you who are using Teams. I'm not sure about those of you who are using the web. I'm guessing you can also hear them, but with the recordings, what we see is any shared content, basically, and then the voice. So any questions that you ask will be recorded. So you are being recorded, and I believe Microsoft Teams will actually display a message that you're being recorded as well.
Yeah, it does for me at least. Recording has started. Participation in the meeting indicates your consent to being included in the meeting recording.
Yes. So I am getting requests from one of my students that if you're not in the middle of talking, to mute your speaker and just unmute when you're talking, because they're getting a lot of feedback. And I guess that's especially true if you're using a laptop speaker, a microphone, sorry. So anyway, that was a request from one of your fellow students. So I'm going to go ahead and share. Let's see. Okay. Screen one. Oh, here. So can you see that?
Yep, got it.
Okay.
Yeah, I can see it.
Great. So welcome back to class. We have Software Engineering 1, the online edition. So let's see. There was something else. Okay. So anyway, okay, so our devotional for today is meant to be encouraging. It's 2 Corinthians 1:3-7. Blessed be the God and Father of our Lord Jesus Christ, the Father of mercies and God of all comfort, who comforts us in all our afflictions, so that we may be able to comfort those who are in any affliction with the comfort with which we ourselves are comforted by God. For as we share abundantly in Christ's suffering, so through Christ we share abundantly in comfort too. If we are afflicted, it is for your comfort and salvation, and if we are comforted, it is for your comfort, which you experience with you patiently endure the same sufferings that we suffer. Our hope for you is unshaken, for we know that as you share in our sufferings, you will also share in our comfort. So is anyone experiencing great stress levels right now? I imagine it's been kind of stressful moving out and moving forward with the semester, but I'm hoping that you can take comfort in this message. So anyone have any, I'll go back, anyone have any comments about this particular devotional verse? Okay, I'll take that as a no. I didn't hear anything, but if you do have something, please go ahead and chime in. So again, we will be eventually having the study, the midterm. So the study guide is available. I will let you know when I decide the midterm is. The midterm will be taken solely online in your free time, so you get to schedule when you're going to take the midterm. And then the first assignment coming up here is the March 25th prototype and project description. And I think that should be straightforward because it's not too much more than your project proposals. It's pretty much your project proposal in a document revised with any new thoughts that your team has on it. And then the prototype screens, most of you had prototype screens, but again, they can be rough, either PowerPoint screens or Visio diagrams or even hand-drawn diagrams. And if you do hand-drawn diagrams, I would suggest if you have a scanner, scan it in and just submit a JPEG or something, or take a picture of it and upload that to Canvas. I believe you should be able to upload pictures to Canvas. So anyway, that one I think should be low-hanging fruit, should be easy. If it's not, think about what you're doing, and maybe you're making it more complicated than you have to, and go ahead and get in contact with me if you're having problems. And then Friday, we will have online quiz for Chapter 7, Design, Architecture, and Methodology. Again, that will be taken online by yourself through Canvas. The password is grandchildren. I will try to send out a message about that as well so that you know what the password is. Actually, you know what? I might just take off the password since I'm telling you all the password up front and you can take it on your own leisure. Maybe I'll just take off the password. So maybe I'll do that. And then Monday, March 27th, the requirement specification is due. For those of you who participated in the test meeting,
Can I interrupt
yes.
real quick?
Sure.
Is that going to be the 30th? Because the 27th is the Friday.
Oh, I'm sorry. This should be Friday.
That should be on Friday.
Yes, that's on Friday. Now, it sounds imposing, but let me tell you how I do the requirements submission from the team and the design documents. Basically, you submit what you have. I do comments, or we talk about it in class, the various requirements, and you're allowed to resubmit as many times as you want and get additional points. So you can think of it as your best cut first draft of your requirements, and knowing that please get in at least a draft, your initial requirement specification, but also know that you can continually keep resubmitting your requirements to get additional points based on comments that I either give you in Canvas or that I mentioned in class. So there it's pretty open-ended once you get that initial draft of your requirements specification in. So I'm hoping that that's not too difficult. So yeah, I actually was doing a copy and paste from a previous slide, and it ended up being Monday, but it should be Friday, March 27th for the requirement specification. Sorry about that, but it is Friday. Again, consider it a draft of your requirement specification because you're allowed to keep resubmitting throughout the semester. I mean, all the way up to the final, you're allowed to keep resubmitting your requirements. Same thing with the design. And then, so what we're going to go into here is testing and quality assurance will be our next lecture, and it's our last major topic to be covered. And after that, we will have some additional lectures on material, but the main emphasis will be actually on your projects as your teams. And please let me know if you have problems getting a hold of your team members so I can try to assist you in taking care of that. So the other thing is my plan is for Wednesday to discuss this UML design problem some more that we started seems like so long ago before spring break. So we're going to be looking again at this UML diagram for elevators. So I'd like you to try to come up with initial design of a class diagram and the relationships between the classes. If you could draw that up, I will definitely give you points and credit for doing that. And then we will then also move on to doing state diagrams of the various classes that you identify. So that is my plan for the next lecture. So. Okay. And on to testing and quality assurance. So did you all hear that beep as I unplugged something from my USB? Probably not. Hopefully
I
not.
didn't.
I didn't hear anything.
Yeah,
Okay.
I
I did
did.
not, no.
Oh, that's good.
Nope, nothing for mine.
I am, let's see, setting an alarm so that I don't miss the end time for this class. But we're in good shape. All right. So and okay. So how about that? Can everyone see the slides, I hope?
Yeah, I can. I can.
Yes.
Okay.
Yeah.
So this is chapter 10, testing and quality assurance. This is an important thing to do to make sure your product is sufficient and hopefully that defects are not found by your customers, although they can be involved in the testing process as well. But you want most of your errors to be found before your customers get it in their hands. So the goals of this lecture is on understanding quality and basic techniques for software verification and validation. Again, verification is testing whether the software meets your design and specifications, and validation is it actually doing what the customer wants it to do. Again, it's a subtlety, but it is an important distinction that validation is actually, did you achieve what you wanted to achieve for your customers? And then we analyze the basics of software testing and testing techniques, and we'll discuss the concept of the inspection process, otherwise known as reviews. Reviews is a critical area for all stages of the software lifecycle. So testing, what is testing? So it involves various major areas. First is quality assurance. So quality assurance is all the activities designed to measure and improve quality in the product and process. So in the last company I worked for, we had a whole team involved in basically monitoring responses and customer support questions from people in the field and complaints from people in the field, measuring that activity and trying to characterize it so that we know when there's something going wrong in the process so that the process can be corrected. And the process could be software, it could be delivery of the product, all different aspects of the product as well. It's not just the software. Quality control are activities designed to validate and verify the quality of the product through defect, faults, and fixing of the defects. And so this is, although we are involved with the QA and QC process, we're most intimately related with the QC process, the quality control process. And since this is such an important area for delivering good software, good techniques and process and tools, and then there are teams involved, again, like I said, in making this all happen. So first of all, if we're trying to produce quality software, we have to have a basic definition of what quality is. Two traditional definitions is that it conforms to requirements and it's fit for use. Basically, it does what the customer wants it to do and it does it reliably. Reiterating what I said in the goals, we have verification is checking software conforms to its requirements. Did the software evolve from the requirements properly? Does the software work? Also, does it conform to our design? Is the system correct? But just because the software is correct, again, you may have missed the boat on requirements and it may not serve the customer needs, and that's where validation comes in. That's checking software meets user requirements. Is it fit for use? Are we building the correct system? Are the requirements correct? This you will definitely have heard of beta testing and early testing, and then my company actually did a validation release where we sent it to key customers that were called thought leaders, but basically they are the customers that influence other customers, and so they are given an early pre-release, and they give us valuable feedback on where we missed the boat with our requirements. So some error detection techniques is testing, which is executing a program in a controlled environment and verifying and validating output. So unit tests and integration tests can be considered part of this, but also the software quality assurance team will be heavily involved with this. They will have test plans that outline these controlled environments, and based on various actions and inputs, they have designed and written down what the output should be, and they go through those tests repeatedly to make sure that they work. They test them initially until they work, but they also continue to test them as new revisions come out periodically to make sure that nothing gets broken in the process of fixing other defects or correcting other issues. And the other techniques we have is inspection and reviews, and that is basically getting a team of people together in a meeting, or having it through various tools like our source code control systems will generally have some way to give your software or some other artifact that you've created for someone else to review. They electronically receive it and electronically put comments. So both in-person meetings and electronic reviews happen, and basically the idea there is basically the pairs programming concept, that having more people look at it, you will see things that are missing, because we tend to get tunnel vision as we're working on systems and we miss things. And so also common is even reaching outside the team to other teams to have periodic reviews for people outside, because again, you can get into team think where everyone starts thinking alike and you miss something. So it is also useful to have someone from outside the team periodically test and review your software. And then there's formal methods for proving software is correct. Generally, those are somewhat limited in their abilities, because the amount of times that you can use formal methods is small. So it's not heavily relied on. It's mostly algorithmic things where you can use formal methods. So the ability to use formal methods is somewhat limited. And then we have static analysis, which detects error-prone conditions, which basically takes a look at your source code through some tool, and it looks for common structures or usages that indicate that there might be a problem. So okay. Let's see, did I get a new message? Oh, no, that's an old message. So I'm hoping everyone is getting fairly good quality sound. Let me know if you're not, but I'm not quite sure what I can do about it either. So one thing that we're looking for is faults and failures. So the different categories and types of faults and failures we have is an error. It's a mistake made by a programmer or software engineer that caused the fault, which in turn may cause a failure. So this is miscoding, misdesign. A fault is a condition that may cause a failure of the system. This is a defect or bug. And then we have a failure problem, an inability of the system to perform and function according to its specification due to some fault. That could be outside influences are common as well. And then we look at the fault or failure problem severity. So based on the consequences, we rate how severe the fault is. You will have must-fix problems. You have critical issues that could affect, safety issues or severe failures of the software. Those are something that you want to focus on and possibly look at redesign if that's necessary. But you are always rating the consequences because, frankly, minor defects and bugs that are very minor may get overlooked or might get pushed back to release, or actually there actually may be a decision not to fix it at all. So this is why categorizing defects and faults and failures are critical. And this will also tie into risk analysis, where you have a team of people that are involved in trying to determine what your risks are by deferring. So severity and priority are definitely closely related. Severity will relate to a high priority item. You could have a low severity issue, but still of high priority because it affects how severely affects how your customer uses your system. So testing is activity performed for evaluating product quality and improving product by identifying defects and having them fixed prior to software release. Again, keep in mind that is based on the priority and the severity of the defect. And then one key way of doing it is dynamic, which is running the program and verifying the behavior of your software against various test cases. That's done by both the software developers and your software quality assurance team, and then ultimately by your validation testers, which can be customers, and beta testing. The one thing that keep in mind is testing cannot prove the product works 100%. It is actually, in a large system, almost impossible, I would say impossible, to have a completely defect system. Even though we use testing to demonstrate that parts of the software works, we cannot be assured that every parts of the software will work in all cases. So here's a key idea here. Let's go back here. Yes. So a key here is who tests. That's programmers. That's us in general. And then testers, the software quality assurance people. Then you also have requirements analysis analysts, and we also have the marketing folks who are also getting in and trying out and trying to tell if system is working as they were hoping and will have the effect on the marketplace that they hope. And then validation testing from the users. What is tested? Unit code testing. We talked about how when you're doing refactoring, that unit code testing is critical. And so early on, it's good to have your unit code testing in place. And in fact, we do know that from the agile processes, and in particular extreme programming, they actually advocate test-driven coding, which means that you actually write your tests first before you actually write your code, and then write so that your unit code tests will pass. We also have functional code testing, which is looking at various functionality in the code. This is your top to bottom tracer testing, which you're actually taking all the different levels of your software and all the different components of your software and seeing if a particular function in your code continues to work. Same thing with integration and system testing. You're taking major systems and subsystems, integrating together and trying to see if everything seems to be working together. So you want to do this early in the process, not wait till the very end, because this makes it more difficult if you wait till the very end and all of a sudden something doesn't quite work. So again, the unit testing is the individual units, module classes, and methods. Functional is functional specific functionality in the system to provide a specific function. And integration is multiple subsystems or the complete system integrated together and tested. So why are we testing? Certainly acceptance by the customer, especially if it's under a contract, will be important because that's how you'll get paid. We want to have conformance to the standards and laws, et cetera. So again, my company was a medical device company, so the FDA was definitely involved with testing it, and so we definitely were constantly audit for conformance to best practices for medical devices. We are also testing to make sure that there aren't any configuration issues. Configuration issues is when you have various components of the software and hardware that are put together. We want to make sure that it always works. It is not too it's very common for it to work in a software's development environment, and then when we get out to production, for some reason it's not working because there's a library that's on your system that's not in what we are distributing, or there's a configuration setting somewhere that is on on a developer's system that's not the same as in the customers, and it has an effect. So we have to make sure that we know exactly how the software needs to be configured and put together and what components need to be involved. And we will discuss that in the next chapter, I believe. But you want to make sure that you know exactly what's going out to your customer and what's required to make your system work. And then we do performance and stress testing, security, et cetera. So I think performance and stress is pretty straightforward. We know that web design definitely has to take this into account. How many users can you have accessing your system and doing what before the system performance degrades? We can see this in real-time systems as well, where we're looking at stressing the system and finding out where its weaknesses are in terms of performance. That will be called out in the requirements to what degree or what performance levels you need to do. And then user interfaces, which focuses on your user interfaces and your workflow. How does your customer interact with your system? So how do we test? How do we design test cases? One way we do it is sort of intuition. As you get better at it, frankly, you build up some intuition on what needs to be tested, what are areas of likely failures and defects. Again, for my operating system class, synchronization. So anytime you have multi-threaded code, there should be lots of test cases involved with the multi-threaded code. Specification-based, which is black box testing, you're looking at your requirements and your design and doing test specifications-based testing. And then we have code-based, which are our unit tests in general, the white box testing, where you know how the code is written and you know possible weaknesses that may come about, so you can design your tests based on areas that you know might be a concern. And then existing cases. This is the regression testing. This is where you're constantly retesting things you've already tested as the software progresses and gets developed to make sure that no new issues crop up, or no issues, new issues come up with things that were working previously. And then we look at boundary conditions. Boundary conditions are those edge cases where, for instance, you know that your input is allowed to be between 1 and 100. So what happens when the input is 100? What happens if it's 1? What happens if it's outside the boundaries? What happens if it's 150, where it should be 1 through 100? What happens if it's a negative number? These are all areas that you want to test to make sure that your system doesn't fail when it gets things that are right on the edge of what's acceptable, or gets things that are unacceptable. What happens with your software? So here we see a general progression of the testing. Generally, you start out with unit tests, which are for the most part done by the developers, although I actually have seen teams that actually had separate unit testers who do the unit tests, but it's more common to have the developers, the software programmers, do the unit tests. Then you have your functional tests, component tests, and system regression tests. System and regression tests, again, is primarily the realm of your software quality assurance team and your quality assurance and quality control folks. The functional tests will generally be from the software developers as they integrate up and do tests across system level to test a particular function. Those will be put together by the software team and will often have to pass in order for it to be passed on to software quality assurance. But software quality assurance will also have their own functional testing too, where they're testing out particular functionality as well to give another perspective to prevent the tunnel vision problem. So another technique is equivalence class partitioning, which is dividing up the input into several groups deemed equivalent for purposes of finding errors. You pick one representative for each class used for testing, and the equivalence classes are determined by requirements design specification. So here it's basically a technique of sampling. You're categorizing your classes and trying to pick representative classes for testing and figuring that if it's working one place, that it should be working in the other because it's closely related and similar. Here we have a discussion of the boundary value analysis and this is black box, talked about in your text, but again, this is something I talked about. So we look at the boundaries, outside the boundary, and inside the boundary. We want to make sure that you consider all these cases, and it is typical for the failures to happen from at the boundary and outside the boundary where those cases were not properly handled by the software developer. So here, again, the boundary is set at 12, normal is 11, 12 is at the boundary, and then 13 is outside the boundary. So we look for all those, and it's particularly good for ordinal values, but also for continuous values as well. And I think I gave you an example in class already of a case where a value exceeded a boundary condition. It was deemed not possible, and it was true that it was not possible with the existing system, but we were actually importing some data from a prior system, and that actually did not conform to the boundaries and created problems. So another technique is path analysis. It's a white box technique, so you actually know the code, and you're looking at all the code paths through your software code. We're looking at all the paths, and we're trying to test all the different paths. As you can imagine, this is very difficult to do because the number of paths can grow astronomically and exponentially. So you can look at logical paths, independent paths, branch coverage, and statement coverage. And there actually is tools that will look at your code and your testing and help you determine what kind of coverage you have. Say you have testing of 80% or 50%, or possibly if your code is simple enough with not a lot of branches, you could have 100%. And there are tools that will actually state how much testing, how much coverage you have in your tests for your source code. Again, this is a white box technique. You have to know your code. So here we have a linear independent set of paths, and there's a table that's created here. This is, again, from your text. And there's a chapter that we skipped that talks about McCabe's cyclomatic number, which is a measure of complexity. So those numbers will generally be generated by a tool. But you can see here that for path one path is we go from, let's see, can you see my cursor? Probably not. Anyway, we go from path 1, and then we go through the decision tree C2 and go to path 5, and then we go to path 6. Path 2 is we go to 1, we go to C2, but we go to 4, and then we drop down out of the system and not even go on the path 6. So you can see here, these are the various paths that can be progressed through this flow chart of a piece of code. Again, this is impractical in many cases because the complexity and the number of paths, you can't possibly cover all the paths in most instances. And so a lot of times we will just try to analyze what kind percentage of the coverage to see how good our coverage is, and also looking at those error and boundary conditions will also determine what paths we go about testing. So we have combinations of conditions, functions that have several related variables. We want to be able to test all the different combinations of the variables. And this is very common to do in especially critical sections of code, where you will actually create a matrix of the variable combinations and use that to lay out your tests. Very important because in some of these critical areas, it is catastrophic if an area is missed, and certainly we did this a lot in our medical devices because of the criticality of certain portions of doing a misdiagnosis or actually possibly harming the patient. So there, that kind of analysis was critical. Again, coverage analysis, we talked about that in terms of paths. We want to determine how much coverage you have and assess how important the function is in determining how much of the permutations or combinations you're going to test. You will sometimes have to do sampling if there are too many relations to possibly test it with a reasonable amount of time and resources. Again, unit testing is important for a software developer. You want to test each individual unit. That's a method or a function generally, and it's usually done by the programmer. Again, I've actually seen teams that had separate programmers for unit tests, but it's a lot more difficult. Actually, it's only when you're really stretched for resources, because you're trying to use as many resources as you can, because there's a lot of communication that has to be done between the programmer and the unit test writer. And then we test each unit as it's developed, small chunks, Catching it early makes it easier to find the source of the problem. So we want to do it as we're developing the software, or again, in the case of test-driven code, we actually write the unit test before we write the actual code. There are also various tools that are available for creating your unit tests. They basically create an automated skeleton of your unit test based on your code. So if you've written the code already, you can run a tool and it will automatically generate the framework for your unit tests. So I miscapitalized JUnit there. It should be J, capital U. JUnit is a tool for Java, and there's also certainly tools from Microsoft as well, that and then also third-party tools that will generate unit tests for you automatically from your source code. Key things here is it allows for regression testing and facilitates refactoring, because you don't want to be refactoring if you don't have unit tests that you can verify that the refactor code becomes that the refactor code becomes a defect and causes a problem. So we want to make sure that we have unit tests in place before we start into the process of refactoring. And the other interesting thing is that your tests or your unit tests become essentially documentation, because you are testing the boundary conditions, you're testing the major functionality in the areas. So if you look at your unit tests, it will tell you specifically what this particular method is supposed to do, method or function is supposed to do by looking at the unit test. So here, again, is a write-up of what I had talked about earlier. In extreme programming, we look at test-driven development, and there's actually a test-driven development push for even from outside the extreme programming realm. So this is not hand in hand. You don't have to be doing extreme programming to do just test-driven development, but it's writing the unit test case before the code. And so essentially your test cases, your unit tests become the requirements. And so you are writing your code or implementing your code directly against your requirements, which are your unit tests. And you know instantly if you've written good unit tests when your software has met the requirements. So the steps are: write test cases in code, verify it fails or runs, modify code succeeds, rerun the test cases and previous tests, and then you can refactor until success or satisfaction. So either you're factoring until you get it successfully working, and then you can also refactor to make it, to get rid of ugly looking code, or as our previous class we talked about in implementation, smelling code. We can get rid of all code or the broken windows effects, basically code that's going to cause problem down the road. We can fix that and refactor it and have the unit test to verify that it's still meeting the requirements. So here's a big question we have is when to stop testing. This is a very interesting question and a difficult question, and certainly the marketing department and the management will have a lot to say about this because they want that product to go out the door. But the simple answer is all test cases are executed and all problems that are found are fixed. That may not always be possible in terms of all problems that are found are fixed. And the other thing is you have to have good confidence that your test cases are sufficient to verify that your software actually is functioning as specified. Other techniques is when your defect rate, stop when you're not finding any more errors or your defect rate is small, it's longer and longer between the finding of defects. You can say, okay, our defect discovery rate has gone down to an acceptable level. We're going to call this good. And the other technique is actually purposely seeding defects into your system and waiting till some percentage, like possibly 100% or 90% of the defects that are seeded into the system are found by your testers. This particular technique, in my mind, it sounds very dangerous because what happens if you accidentally leave in some of your seeded defects in your system? That would be a bad situation. So you would definitely have to have good documentation, but it does worry me about defects accidentally being left in or causing a defect in the process of removing the defect, that there was some error in that process of removing the defect that was seeded in there. So, but anyway, that is a possible technique. The one solution that is definitely a bad solution, and which is something that you will need to fight against from management and marketing, it's not when you ran out of time or when the schedule says you should be done. That's poor planning and could result in all kinds of issues. Defect seeding, again, it's a statistical process that where you discover your defects. This is talked about in the textbook. I won't go too much into it, but this is what the curve would possibly look like for your find rate, both for seeding or even for the case where you're not actually seeding defects. But what is graphing out? What is your defect finding rate? The other very valuable tool is inspections and reviews. Again, this is not just in the testing realm, but design requirements, all levels of the software life cycle, all stages of the life cycle. Inspection and reviews are very important and very cost effective. It costs very little to do inspection and reviews in terms of the grander scheme of other testing, and it's very valuable in discovering defects. So it involves human testers reading and understanding a document or source code and then analyzing it with the purpose of detecting errors. We walk through with the author explaining a document or artifact or source code to the team of people. Again, it's becoming more and more common to do this electronically as well, so they're not always in person. If you're having a meeting, you want to have various roles and responsibility. The author generally will explain the document or artifact since he knows it the best, but you don't want your author to also be taking the meeting minutes. You should designate someone who's responsible for meeting minutes. You want to have someone else that's responsible for timekeeper, because you don't want your reviews and inspections to take too long, because the quality of your inspections severely goes down the longer you're sitting in that room. And I think I explained to my class that I had a situation where I was working where a lot of the important reviews that we required by our software development process were put off until the end, and we were basically locked in a room for days and given lunch, and we worked through lunches, and the quality of those walkthroughs inspections were horrible. So you definitely want to have a designated amount of time that's reasonable, that you could have. It's reasonably expect to have people's attention spans. The other thing is valuable is handing out to the participants in the inspection or review, giving that out to your reviewers ahead of time so that they have the opportunity to look at it ahead of time, and that you're not doing it all in class or in your meeting. Sorry. So that was my 5-minute warning. So then the other one is software inspections. Again, that's just a type of review One thing that's important for inspections and review that is critical, and I can't emphasize this enough, and this is something that you will have to generally fight with management on, and that is that management and people who are responsible for evaluating and giving raises and salaries to the employees should not participate in these meetings. That is not the purpose of these meetings. A meeting that you give a presentation or something would be better suited for that. But the purpose of this meeting is not to evaluate the ability or the work of the reviewer. It's to find defects. And as soon as you get involved, managers and management and people who are actually responsible for evaluating the employees involved, that shifts the focus of the meeting and is very detrimental to the process. So I will definitely emphasize that that is a battle that you will often have, and you will have to kick out managers and say, no, you're not invited to this meeting. So anyway, that's all I have for today. Are there any questions as we finish out? So I don't hear any questions. I'm going to put a chat message just in case someone couldn't hear me. So anyway, have a great rest of the day, and
Wait,
I will. Yes, go ahead.
Isaac asked if you could go over any upcoming assignments.
Okay. So the upcoming assignments were let's see, I'll bring up the other presentation. Thank you for helping out your fellow student there. So, oh wow. Team actually saw that I brought up this slide and asked me if I want to share it. Oh no, wait a minute. That's not the same. Let's share screen one desktop. Okay, can you see my screen here? So Isaac, can you see my screen or his designee? I think I'm sharing the screen. Anyway, so again, the coming assignments is the prototype and project description for your class project. So your team, that's basically taking your project proposal, putting it into a document and updating it with any changes you've decided on as a team. So that's due Wednesday, March 25th. March 27th, there'll be a quiz. Again, that's online at your own time. I had the password as grandchildren, but I think I'm just going to take the password off because there's no purpose in the password. And then the requirement specification is due, this is incorrect, due Friday, March 27th, and that is your rough draft of your requirements. There is a template. If you go into Canvas, there is a template you can download from which you can start doing your SRS, your software requirement specification. Please use that template and take out. I have italicized text in there that gives you hints about what I'm asking for or what's being asked for in that section of the specification. Please remove that before you submit it. And then also remember that I want your requirements to have a unique identifier so that each requirement can be identified by some identifier, basically a number, a combination of letters or number, but some type of basically it's like a variable name, if you may want to think about that. And so does that answer the question in terms of the assignment, or did I miss what the question was regarding? Okay, so Isaac says yes. All right. So anyway, thank you all, and have a great week.
Salim,
Yes.
There
sorry,
was
one more thing. Michael asked, would you like the prototype and project description document with a specific format? So yeah, would you want a specific format for that, or
No.
just in a Word document?
Yeah, Word document would be great, but there is no set format for that. It's basically, what does my project do? Why is it useful to my user? And then there's the draft look of what you think your screens might look like. Again, they can be handwritten if you want, or all the way to that to Visual Studio code that shows the interface, but there's no functionality behind it. Anywhere there, if you go the Visual Studio route, that will take you forward in your UI prototype, which is a coming assignment. But if you just want to write it out and scan it in and submit it as a JPEG or whatever, or take a picture of it with your phone or whatever and upload it, that would be fine in terms of the prototype screens. If you want to paste it into your Word document and submit it all as part of your Word document, that would be excellent. That would be an excellent project description of having your prototype slides in your presentation. Whatever you want to do is fine. But basically, it's just taking your PowerPoint presentation and modifying it for whatever you've decided is best. You know, whatever you decided, what you've changed, any way you've decided to update it, like descoping the project, for instance, would be one example. Or, oh, we said it was going to do this, and we decided no, it's better if it does this. Those kinds of changes would be reflected in this Word document per se. So, any other questions?
So the midterm will most likely be pushed farther back than Monday the 30th, correct?
Yes, most likely will be pushed back. Yes, it will be pushed back beyond the 30th for sure. Because I want to cover in class a little bit more the UML design methodologies of a class diagram and state diagrams before the midterm. Hint, hint, guess what? There'll be a problem that will ask you, and if you look at your test guide, yeah, you want to be able to do UML class diagram and a state diagram, and you even know what the problem is because it's in the study guide. So there's a big hint for you. But yes, it will not be Monday for sure.
All right, thank you.
Yep. Anybody else? Okay, well, you're certainly all excused. And if you want, send me an email message of how things went and what you think might be something that can be done to improve the process. But I will see you next Wednesday. And again, I will send out that PowerPoint slide with the UML design problem. But I think I will go ahead and finish up the testing since I'm almost done with all the slides for the testing. And then we'll start in on the UML design problem. And we'll probably do that Wednesday and Friday, I'm guessing, but we'll see how things go. All right. Well, thank you, everyone. It was nice hearing from you, those of you who spoke in class. But again, certainly chat is another way to communicate with me. So have a great day, and I hope things go well for you for the rest of the semester. Take care.